A corona discharge is an electrical discharge brought on by the ionization of a fluid such as air surrounding a conductor that is electrically charged. Spontaneous corona discharges occur naturally in high-voltage systems unless care is taken to limit the electric field strength. A corona will occur when the strength, potential gradient, of the electric field around a conductor is high enough to form a conductive region, but not high enough to cause electrical breakdown or arcing to nearby objects. It is often seen as a bluish, or other color, glow in the air adjacent to pointed metal conductors carrying high voltages, and emits light by the same property as a gas discharge lamp. In many high-voltage applications, corona is an unwanted side effect. Corona discharge from high-voltage electric power transmission lines constitutes an economically significant waste of power for utilities. In high-voltage equipment like televisions, radio transmitters, X-ray machines and particle accelerators, the current leakage caused by coronas can constitute an unwanted load on the circuit. In air, coronas generate gases such as ozone, O3, and nitrogen oxide, NO, and in turn nitric oxide, NO2, and thus nitric acid if water vapor is present. These gases are corrosive and can degrade and embrittle nearby materials, and are also toxic to people. Corona discharges can often be suppressed by improved insulation, corona rings, and making high-voltage electrodes in smooth rounded shapes. However, controlled corona discharges are used in a variety of processes such as air filtration, photocopiers and ozone generators. Introduction: corona discharge is a process by which a current flows from an electrode with a high potential into a neutral fluid, usually air, by ionizing that fluid so as to create a region of plasma around the electrode. The ions generated eventually pass charge to nearby areas of lower potential, or recombine to form neutral gas molecules. When the potential gradient, electric field, is large enough at a point in the fluid at that point ionizes and it becomes conductive. If a charged object has a sharp point, the electric field strength around that point will be much higher than elsewhere. Air near the electrode can become ionized, partially conductive, while regions more distant do not. When the air near the point becomes conductive, it has the effect of increasing the apparent size of the conductor. Since the new conductive region is less sharp, the ionization may not extend past this local region. Outside this region of ionization and conductivity, the charged particles slowly find their way to an oppositely charged object and are neutralized. If the geometry and gradient are such that the ionized region continues to grow until it reaches another conductor at a lower potential, a low-resistance conductive path between the two will be formed, resulting in an electric arc. Corona discharge usually forms at highly curved regions on electrodes, such as sharp corners, projecting points, edges of metal surfaces, or small diameter wires. The high curvature causes a high potential gradient at these locations, so that the air breaks down and forms plasma there first. In order to suppress corona formation, terminals on high-voltage equipment are frequently designed with smooth large-diameter rounded shapes like balls or toruses, and corona rings are often added to insulators of high-voltage transmission lines. Coronas may be positive or negative. This is determined by the polarity of the voltage on the highly curved electrode. If the curved electrode is positive with respect to the flat electrode, it has a positive corona. If it is negative, it has a negative corona. See below for more details. The physics of positive and negative coronas are strikingly different. This asymmetry is a result of the great difference in mass between electrons and positively charged ions, with only the electron having the ability to undergo a significant degree of ionizing and elastic collision at common temperatures and pressures. An important reason for considering coronas is the production of ozone around conductors undergoing corona processes in air. A negative corona generates much more ozone than the corresponding positive corona.